Hey, hello and welcome to the show. It's me, JP. It's time for JP's product pick of the week. We have arrived here together and we're ready for this moment. Thanks everyone for stopping by. If you are over in the YouTube chat, hello. Hey Eric, hey Tackle the World, hey Backwoods Engineer, nice to see you. If people want to head over to our Discord chat, there's a bunch of people here. Look, that's it right there. That's the Discord chat. You can go to adafruit.it/Discord. You'll get an instant invite and you can join our server, and then you can jump over to the live broadcast chat channel. It's where the things are happening. So let's see. Let's jump right into this thing. The first thing I want to do is send you to a very special place, and that is this QR code or URL right down here, where you're going to see that this week's product pick is 50% off, and you can watch the show from right inside the product page, which is really nifty, we think. So head on over there if you don't mind a spoiler, but you'll only have to wait a few moments to find out what that product pick is, because I'm going to have Lady Ada introduce it. Please take it away, Lady Ada.
Feather Cricket. Okay, so
And
now we're talking.
Like feather. Now you got this.
So the Cricket is our robotics development board that offloads all of the work that you would need to do with robotics. You can drive 4 servos, 2 bidirectional DC motors, has 4 capacitive touch inputs, 8 analog and digital signal I/O pins that you can use to read potentiometers or buttons, 4 drive pins that are connected to Darlington transistors. You can connect 2 steppers to it if you want, or 4 servos, 2 DC motors. Like you have it doesn't do like everything, but it does just enough to get what you want done. And what's best is it's got a nice power supply system. You power it from 5 volts, and all the stuff on here is 5 volts. So it's 5 volt drive, 5 volt motors, which is pretty good. Most hobby stuff is 5 volts, especially the servos and motors. And then it has NeoPixel with a buffered NeoPixel output as well, and an on-off switch here, and it even has protection. So if I take a 12 volt adapter and you plug it in,
It's okay.
it's okay. It just says like, hey, your power is too high. It's got this cool protection chip on it that I found. So yeah, you got your H bridges, ULN 2008 drive.
Want to do IoT robotics, Bluetooth robotics? You got all
great.
of the Feather ecosystem with robotics.
It works with any Feather, and the reason it works with any Feather is that it has Seesaw, which is our I2C to anything converter chip. So everything on this board is managed over I2C. So even if you have an ESP8266, something that doesn't have almost any pins left over after you use I2C, because everything's used for either bootstrapping or the LEDs, it's fine. You can still get those 8 analog inputs, 4 capacitive touch, 2 motors. Like there's no worry about like, do I have enough timers on my what's it, or what if I have a chip that can't really drive NeoPixels? Not a problem. You plug the Feather in, and this chip does all the I2C conversion for you, and we have Arduino and make code and CircuitPython code for it.
Okay.
So it's great for. And then, of course, you can stack feathers and featherwings on top. So you have a feather and then an OLED featherwing, and then you need more servos, you can add a servo featherwing on top. So you can just keep climbing up with the feather plugin system as well. So this is great for people who have feathers and they want to do robot projects.
Hey, I'm convinced. I'm going to run over to my magical mystery cabinet full of wonder drawers and go grab one. I'll be right back. Yes, there it is. It is the product pick of the week. It is the CRICKIT FeatherWing. So just like all of our other Crickets, this is an all-in-one robotics platform, and we have these for different microcontroller boards, but this one's pretty special because it accepts any feather in the feather ecosystem. What's cool about that is it means that if you want to use an RP2040 feather, you can do it. If you want an M4, go for it. If you need Wi-Fi for AIO types of connectivity, you can use an ESP32 based chip. If you want to do some Bluetooth things. You can get an NRF52840 feather, for example, and plug it into there. This handles all the power for you. It takes everything and drives it at 5 volts, even if your chip on your microcontroller is at 3 volts. We have DC motor driving, we have stepper driving, we have servo motor driving, we can read capacitive touchpads, there's 4 of them on here. We can read a bunch of sort of digital signal pins and analog signal pins. What else have we got? We can drive NeoPixels from here. We have an amplifier built on board, so you can drive a speaker. And it makes it really easy to decide what you want to plug together to build a project. So first thing I'll do is actually let's head over to the product page and take a look at this. So here we can see on the product page, these were out of stock right before the show. Someone said, yes, we stash a bunch so that we can have them ready to go for the show. Looks like we've sold a bunch already. I think we had a lot more than 12 to start with. But that's a great price, $14.98. Makes a great present if you want to gift yourself something to do some robotics types of things over the holidays. It's not a bad idea. And if you take a look at the page here, you can see we've got some views of the product. We have a nice little feather plugged in right there on top, you can see. There's the back of the board. And we have a description of the board, tells you about its capabilities, and then we have a link to some of the projects you can do in the Learn system. Here is the introducing the Cricket product page or Learn guide rather, and this really refers to any of the Crickets. So this is, you see a picture here of the Circuit Playground Express version, but it works pretty much the same for any of the boards that you can plug into any of the versions of this. And it shows you how you can run this with, I think in this case, I don't think MakeCode will work. Maybe Maker.MakeCode does, but we definitely have CircuitPython examples and Arduino examples, as well as libraries to make that really easy. Here are some here are some projects that we've built with them that there are full Learn guides on. This one's pretty neat. This is a Bluetooth-driven little rover bot using a couple of DC motors and a Bluetooth-based feather plugged into it. And you can see here we also have the Bluetooth light switch. I'll demo that one in a second because I have it sitting right here, right behind me. And then there's a guide here by David Stells on using Cricket and Adafruit I/O, which is really pretty convenient. So if you have a Wi-Fi based Cricket plugged or feather plugged into your Cricket, you can do Adafruit I/O things where you can have things react to Internet of Things in the physical world, thanks to the Cricket driving motors and such. We also have this little bumper bot. This one, you'd probably want to use a feather that has an accelerometer, or rather an add-on going into it, like the Prop Maker FeatherWing, because this one reacts to bumps. Here's a little mini golf course. So there's a lot of examples of things you can do with the Cricket that you can check out in the Learn guide. What I want to do right now is show you a few little examples. So let's jump to my down shooter here. And you can see here I've got that Cricket I was showing earlier. And I have 4 wires plugged into this section here, which can either be a couple of DC motors or it can be a stepper motor. So I have a nice little stepper plugged in here, and I just put a indicator there so you can see it turning. And then I'm just going to put a Feather M4 into here. So as long as you have pins soldered onto the bottom of your feather, you can plug that right into the board. And then you could also stack if you use stacky headers. If you have other feather wings you wanted to put on top of it, that would work as well. And now I'm going to give this power. So you normally will code using USB, little micro USB for the feather. You can update the firmware on the Cricket using this micro USB, although you usually don't need to worry about that. And then we can feed it 5 volts right here. And we have the on-off switch. So when I flip that, the code here is just going to tell this stepper to go back and forth a full 360 degrees. And one of the really neat things about using Cricket is that, here, let me get my focus. There's a little focus for you. One of the neat things about using Cricket is the library. So if you take a look at the code I have running this here, get those into view. I have really simple code. I'm importing the time library so I can do some pauses. I'm importing the Adafruit Cricket library and the motor library. And then I'm setting up a stepper by just calling cricket.steppermotor. and then we can set up a interstep delay. I'm using 0, just letting it go as fast as it can, as well as the number of steps I want to run as a little variable here. And then I'm just running forward and backwards in my main loop by calling stepper motor 1 step, so that's just moving one coil at a time, lighting up 1 coil at a time. Actually, no, sorry, this is in double mode, right? Stepper double. So stepper mode 1 step in the forward direction with the style being stepper double, so that's actually pairs of coils inside of the stepper. And then it runs that again backwards. So that's a real simple example of something that you can do with minimal code. Makes it really easy to drive precise stepper action. Now if we take a look at the wall behind me here, you can see, if I take my phone, and I'm using the Bluetooth Connect app right there, if I press the up button, I'm moving a servo motor that's plugged into one of the 4 servo slots on the Cricket. And the way I'm controlling it is that I have a Feather NRF52840 plugged into there, so it's Bluetooth friendly and easy to control. And that allows me to do this just directly like a remote, but you can also do Adafruit I/O types of things if you instead had a Wi-Fi based Feather plugged into there. And then to show you some of the fuller extent of things that you can do, you may recognize this project. It's one I did around Halloween, and this is taking over an animatronic doorbell using a Cricket. I have a Feather NRF52840 here, and if I turn this on, you can see my Cricket comes to life, my Feather is up and running, it's ready to go. And based on the things that I have plugged into this Feather, I'm running 2 different DC motors, I'm running an LED, I am running sound files that are playing over the amplifier into the speaker that's built into the doorbell, and I'm reading this button that's built into the front. So running it with some batteries here, if I press this, it's going to play back a terrible knock-knock joke.
Luke.
Luke who?
Look through the peephole and find out.
That's terrible. So this is an example of taking a whole bunch of those capabilities of the Cricket and putting it into one animatronic device. So robotics, you might often think about things with wheels moving around, but also this type of animatronic is perfect for driving with the Cricket. Let's see, let's see if anyone's got any questions about this. I'll check in with the chat. Oh no, it looks like it's out of stock already and it was in your cart. I'm so sorry to hear that. They went quick. I will hope that you at least consider putting your email address in on the remind me when it comes back in stock. Of course, you won't have the excellent discount, but maybe if you wait for an Ask an Engineer show, you'll get a coupon during Ask an Engineer and you can get one. Let's see. And anything else? Yeah, the library makes it really straightforward. Rich Sad was asking about the library. If we go back over to the Learn Guide here, the main Learn Guide, and look at the CircuitPython code section, make sure you can see that, you'll see that we have everything from driving servos using the Cricket library. So here it's very simple setup. Import the Cricket library and then set up Cricket Servo 1, Cricket Servo 2, 3, and 4. Down through drives, so this can be things like electromagnets and solenoids that require a lot of current, to code for capacitive touch reads. And again, all of this is done with the Cricket library, so it's straightforward. Oh, I've closed the wrong window there. Touch here, CircuitPython touch. Again, this is import Cricket, and then just say Cricket touch 1 value, touch 2, 3, and 4. So really nice. I like this. It's kind of like our Circuit Playground libraries that make things consistent across the entire board, which also makes it really great for people who are learning, for classroom types of situations, because you'll have a sort of sameness to the types of commands that you call on the board. All right, well, I think that's going to do it. That's the product pick of the week right there this week. It is the CRICKIT FeatherWing. It allows you to also connect up using a bunch of mounting holes to your gizmo. You can see in this case, I just used some zip ties to hook that up to this, this little box there. But I'll go ahead and turn this off, and unplug that. Let me pull the feather out of there, and in fact, I'm going to also unscrew these. So these are all small terminal blocks, screw terminal blocks. So you can just get in there with a little screwdriver, loosen those up, which makes connecting pretty easy. You don't have to worry about having a particular type of connector on your board or on your devices. And the one thing I forgot to do, I forget this sometimes, is to give it a way to hook up to the board here. So you know what? I'm just going to grab a zip tie. Speaking of zip ties, I'll pop one through right there. And that way we can hook that up to the wall of products. There we go. Little hanger, makes it easy. All right, so that's the product pick of the week this week. It is the CRICKIT FeatherWing, your robotic friend. That's going to do it for this week, and this is going to be the last product pick show of this year. I'll be out the next 2 weeks for the holidays, so I look forward to 2022, don't you? And I'll see you then. Thanks, everyone, and for Adafruit Industries, I'm John Park. Bye-bye.